Hello, everyone, and welcome to the second lecture of Stata webinars, or the series with Dr. Mahmoud Al-Matkuri, Bismillah. So today, inshallah, we'll continue our second lecture about the random and the fixed effects and other thing, inshallah. So as always, I told you that if you have any question or anything you want to ask Dr. Mahmoud after his presentation, and also this webinar is already live in YouTube. Please don't ask in the chat, because the chat will keep rolling and we can't catch your question. So you have two options to ask Dr. Mahmoud. Just raise your hand and we can go one by one to ask Dr. Mahmoud directly, or you can type your question in the Q&A below the screen. Thank you so much, Dr. Mahmoud. The floor is yours.
Thank you very much, Dr. Ahmed, for the invitation. And good evening or good afternoon or good night, everyone. It depends from where you are joining us today. So today is our part 2 of the Stata analysis series. So we're gonna cover today the panel data, which is very important and the heart of any research. How to do the main analysis, pooled OLS, fixed effect and random effect regression, and if the time allow us, we might go as well through different regression analysis. So as we said last time, that the statistical part of your research paper or your dissertation will have to have 3 main components. The first one is the descriptive analysis, and we done that last time, how to clean the data, how to test the data for normality, how to make that we don't have outlier, and how to take the correlation table and the descriptive statistics table outside in a publishable format in Word file. Today, we're going to go in the regression analysis, which is the heart or the main important part in your regression, in your statistical area or statistical section in your research paper or your dissertation. So please, if you have any question, you can ask at any time. So what we covered last time, we covered data management and descriptive statistics. Today, we're going to cover the main regression models and robustness check models. And next time, we'll start to do in the additional analysis, such as how to tackle endogeneity, GMM, subsampling, structural and equational modeling, DID regression, etc. But today, our main focus in the main regression model. Right? So let's start by the same database I shared with you last time. This is just a dummy base for us to use it today. So as you remember from last time, in the right hand side, these are the variables, and we learned together in the last week how to rename the variable and how to label the variable. The middle section here is the result section. Left hand side section is a history, when you can see your previous command. And here, this box is a command section. So I can write here any command. If I say, for example, sum, and I sum board size, and I press OK, that will give me board size has 962 observation. The mean is 8.7, the minimum is 3, and the maximum is 16. So we learned last time how to do this descriptive, clean the data, so the data is ready for us. What's important if you didn't attend last time class? The most important thing, you have to identify the data to Stata. So the last part we ended by last time, the command, if you remember, say xt set group ID year. This is a very important before we run any regression analysis. And what is the xt set group ID year? Is telling to Stata that our data is run by the year with a group ID. So we identify the data to Stata as a panel data, because we are talking about panel regression. So this command has to be implemented before we start run on any regression. xt set group ID year. And last time we discussed what if you face problem with this command, and you have to clear the duplicate, etc., etc. So you can go back to the previous class and previous recording and come back to us if you have any question. For people asking the chat, yes, it will be recorded. Yes, just please make sure that you type question that is related to the class. We don't want to disrupt other. So if any non-urgent question, you can keep it at the end so we don't disrupt the flow of the class. So starting from the beginning now, right? We have on the right-hand side our data, and we learned last time how to import our data from Excel file. We have in the left-hand side is a history. This is what I was just playing before the class today. So it's irrelevant. We don't need that. And here in the middle is a result, and here's the command section. So run OLS regression. The command for that is reg, or you write the full word regress. So you have two options. The first option is just to run reg, write reg. The second option is to run regress. So both of them will give you the OLS regression. Whether you write reg only or you write the full word of regress. Now you have to be putting here the first variable is your dependent variable and dependent variable. So if you are measuring the impact of gender diversity on the profitability, so the profitability will be your dependent variable. If you measure the impact of board size on earning management, so your earning management will be your dependent variable, right? So the X variable. So you start by your dependent variable. So if I want, for example, to measure gender diversity effect on the profitability, so the first variable here will be the profitability. Let's say, for sake of argument, you are measuring the profitability by return on asset or return on equity. So I press here in the command to take the variable return on asset next to my comma. So I write the first variable is my dependent variable, following by my independent variable. So if you are measuring the link between percentage of women in board and profitability, you will start by profitability and then the gender diversity. Anyway, the names here are just name. You can rename it. So I can just delete all that and I press rename and I make this GD to be gender, for example. The variable will be renamed as gender. So it doesn't matter the name here. It will be different in your thesis or your dissertation. I will put the dependent variable, which is return on asset, for example, the profitability, and the gender next to it. So I started by my dependent variable and then my independent variable. After that, we have to put set of variable. We call that control variables. What control variable? What does it mean, the control variable? Again, this class, it is not a research method. The main and aim of this video or this workshop, it is not teaching research method, because research method will take different contexts and will need much more time and different preparation. We are explaining step by step in Stata. So the main reason or the main rationale for the workshop is to use Stata in the statistical analysis. Therefore, we are not going to dig deeper in the research method. But as you might know, we have to touch quickly that any research method has to have a dependent variable, which is the first one here, independent variable, and then you have set of control. Any other variable that contribute to the profitability other than the gender. You have to select these variables carefully based on your topic, based on your research, and based on the literature in your research. You might introduce new variable. This will be your contribution in your PhD, for example. You might just keep the variable in the literature as it is, but you need to make sure you cover the important variables that control the relationship between gender and return on investment. Because if I run only the regression like that, my examiner or my reviewer or my editor or my supervisor will come back to me and he'll say, how do you know that profitability is only because of women? It might be because the firm size. The bigger the firm, the bigger the profit. Maybe because of the firm age. The older the firm, the bigger the profit. Maybe because of the firm liquidity. The higher the cash, the higher ability to generate profit. So we have to identify set of control variable in our module that all the variable based on the literature that control the relationship or contribute to the profitability other than the gender, right? Basically, in most of the research on accounting, this variable will be divided in two sections. First one is firm characteristics. such as firm size measured by total assets, firm liquidity measured by current ratio, firm leverage measured by gearing, and governance characteristics. For example, board size, board independency, audit committee size. So what I did here, I put some control for the firm characteristics and some control for the governance characteristics. Because obviously, the bigger the firm, the more asset you have, the bigger the profit. Obviously, liquidity, the more liquid you have, measured by current ratio, the high profit you will have. Gearing, the higher the gearing, the lowest the profitability, because you have to pay debt, interest, etc., etc. Board size, the bigger the board, the stronger the governance, the better the profitability. Board independency, more independent board of director, more independent director on the board of director, obviously will increase the profit because we have higher governance power. Audit committee size, the biggest the audit committee, the better internal control, and therefore the profitability will be higher. Again, we are not in this discussion, guys, otherwise I'll be too quick for you now. We are not on the discussion how to choose a variable and which variable is suitable for your model, because this we can separate a different workshop for that core research method and how to construct your model. We're not interested in constructing model. We're interested to run that via Stata, right? So first of all, we put reg, and then my dependent variable, and then my independent variable. So this is my dependent profitability, my independent gender. So the author here claimed that gender will affect the profitability. And then you have some control variable next to that, for example, firm control variable and the governance control variable, right? And I press enter. That will give me the regression result. Slowly, very slow, we need to understand what is this regression tell us, right? First of all, if you look at the table from the start in the far top corner here, you can see 931. And 931 stands for number of observation. The number of observation is the number of variable firm year observation being considered. And the regression model work all the time in the lowest one. So if you have return on asset for 1,000 firm and audit committee only for 931 firm, the regression will run at 931. You understand? So if I run the same regression again and I remove the audit committee, the number of observation might be different. Here is the case that it will be the same. So let's remove board independency, for example, 931. Maybe there is a variable here that make it 931. If I run only return on asset on gender by itself, can you see the number of observation now is 957. So because when you add total asset, when you add current ratio, when you add gearing, when you add board size, that reduce the sample size because some of these variable have some missing data. So for example, when you collect the board size data, it is not full. You have only 930 observation. So when you run the regression, it will go with the weakest number of observation. Anyway, one more time, so we don't forget what we said. We write reg, my dependent variable, my independent variable, and set of control next to that. The first number we look here is the number of observation. This is important for us, so we know how many observation is there. If it's too low, we might change the variable setting, like we remove one of the variable and replace it. For example, if it's too low because of the return on asset, I might replace return of asset by return of equity, which is might have higher number of observation. It shows here lower. Can you see that? It goes down because when I change return on asset by return on equity, the number of observation go down because I don't have enough observation in return of equity. Right? So we'll go back to the main regression, reg, dependent variable, independent variable, set of controls. Number of observations is 931. Important for me as well, the R square and adjusted R square. R square here, as you can see, is 2%, or the adjusted R square is 1%, which is very weak, by the way. But again, this is argument based on the literature. What is acceptable R square in your case, in your literature? So for example, what does the R square mean for us? The R square is the explanatory power of the variable, of the model. Explanatory power of the model. That means this variable explain the profitability by only 1%. That means you are missing a lot of variable. One more time. So the R square is the explanatory power of the model. The higher the R square, the higher your variable are actually capturing the effect on the return on asset. So for example, if I put here only return on asset and gender, the R square is lower now. And you see that it's going down. When you put more variable, the R square go a little bit up. Can you see R square here is 28%? That means this variable explain the profitability by 28%. This is for your understanding. You don't have to write that in the discussion because it's a common information for anyone reading the table. So you don't have to worry about writing all that in your discussion. You just need to understand. Number of observations 701. R square is 28.5% or 28.6%. That means our variable are able to explain the dependent variable by 28%. The higher the R square, the better. Obviously, if you're doing research in medicine, the R square expected to be 98%. Because if the medicine does not cure the disease by probability of 98%, there's no point to use it and to put chemical in your body. So it depends. In social science, accounting, economics, we accept R square low. It depends on the topic. For example, if I do research about narrative disclosure, the complexity of the annual report and the tax evasion, for example. Complexity will explain the tax evasion only by 1 or 2%. So we accept a low R square in this case. So the R square will be, again, there is no benchmark. The higher the better, but you need to look in the literature in your specific topic. If you are doing earning management, you look in earning management literature. If you're doing governance, you look in the governance literature and you see what is the norm of the R square around your specific topic, right? So this is the number observation. This is the R square, the explanatory power in the model. And after that, what is the next important part is to look in the B-value column. B-value column. Can you see B here? B-value column. So you look in the B-value column, any number under 5%, 0.05 is a good result. So any number above 0.05 is actually cannot explain. You cannot explain. For example, in the second row here, can you see the asset 0.915, which is bigger than 5%. Therefore, this line is not explainable. That means by this table, there is no relationship between total asset and return on equity. There is no relationship. Again, guys, ladies and gentlemen, I don't here mean to find a conclusion that total asset does not affect return on equity. It's just for example, right? Because the model might be not enough. I might have to include more variables. I might have to omit some variables. So I'm not discussing the scientific relationship between total asset and return on equity. It just gives us how to interpret the numbers. So I might run this regression, including better variable from the literature, and the relationship will become better. So again, when you run the regression, you look here in the number observation R square, and you look in the B-value column. This is the most important one here, the B-value column. If the B-value is 5% and under, that means this variable is significant. So the relationship can be relied on. If it's under 1%, which is very good, like the first one, that means it's significant at 99% confident level. If it's under 5%, that means it's significant at 95% significant level. If it's under 10%, that means it's significant at significant level 90%. So 95, 99, and 90% confident level is the most acceptable common practice in statistics. So if the p-value is under 0.05, that means it's significant at 95%. If it's under 0.01, that means it's significant at 99%. If it's under 0.10, it will be significant at 90% confident level. Right? So based on what I just explained to you here, how many variables we have significant? Gender is significant because it's 0.003. Current ratio is significant because 0.003. Gearing is significant, which is 0.0000. Board size is significant as 0.31. Right? Another way of identifying whether the variable is significant or not, if you look in the interval here, in this area, the area has to be either in the positive side or either in the negative side. So does not include 0 in the range. So between 17% and 81%, there is no 0 in the middle. Both of them in the positive side of the bell shape. You know the bell shape for the normality. So if the area between 17 and 81, that means between 17 and 81, the 0 does not come in the middle. Both of them are in the positive side of the numbers. That means it's significant. Second one, the number between -1 and +1. Does 0 come in the middle? Yes, this is not significant. And if you look in the p-value, it is insignificant as well. Look in the third one. It's between -5 and -1. That has 0 in the middle. If you draw a line and you put scratch between the -1 and -5, the 0 will not come in the middle. That means it's significant here, significant negative. And the next one, between -10 and -0, again, both of them in the negative side. So the 0 does not come in the middle. That means it's significant. The next one, between 16 and 3.4, both of them in the positive side, which means significant. And the last one has a 0 in the middle, which means insignificant. So how to identify whether it's significant or insignificant? By looking in the p-value, and the p-value has to be under 0.05 or 0.010 or 0.01. So the first one is significant at 99%, significant at 99%, significant at 99%, significant at 95%. Because this one is under 0.05, but it's not under 0.01. Right? It doesn't matter the significant level as long as it's significant. So you can put in your mind one thing, the p-value is below 0.05. You can identify as well the significant by looking the intervaller. So if both number does not cover the 0 area, that means we have a significant relationship. In the far left-hand side here, this is a coefficient, which is very important. And the coefficient will show you the direction of the relationship. For example, gender here. Does the gender significant? Yes. What signal it has here? It has positive signal, it's not negative, which is again confirmed by the area in the positive section. So that means we have a positive relationship between gender diversity and return on equity. The more women we have on board, the higher the return on equity. This is confirmed at 99% confident level, based on 701 observation by R², 29%. Look at the second one, total asset. Do we have a relationship here? Don't fall in the trap and say it's a negative relationship. There is no such a relationship. Why? Because the p-value is high. When the p-value is high, we don't need this row at all. So there is no association between total asset and return on equity. Look in the current ratio, p-value is less than 0.5%. The signal here is negative. Again, if you look here, it will be in the negative area. That means we have a negative relationship between current ratio and return on equity. Every 1 unit increase in the current ratio or the liquidity will decrease the return on equity by -3.14. Every 1 woman will be added in board will increase the return on equity by 0.49. If you look at the gearing first, and gearing is how much debt you have in your capital structure or whatever variable you have. The p-value is 0.000. That means it's significant. The signal here is negative. That means we have a negative relationship between gearing and return on equity. That means every 1 unit increase in the gearing will reduce the return on equity by 0.096. Board size will stand for the number of director in the board of director. The larger the board, the larger the governance power, and therefore the higher the profitability. Makes sense? The larger the board, we have more expertise, different age, different gender, different education background, different capability, different qualification, different ethnicity, different nationality. So the higher the board, the more efficient the company, and therefore the higher the equity, which is again confirmed. The p-value is 0.31, which is under 0.05. The signal is positive. That means every 1 unit increase in the board size will increase the return on equity by 1.807%. Right? So what we did so far, we run the regression. This is called OLS regression. We put our dependent variable, independent variable, and the set of control variables. And what we're looking here, we look in the number of observation, we look in the p-value, the R-square, we look in the p-value that has to be under 0.05. We look in the area does not touch the 0, and we look in the coefficient sign to confirm the relationship or to suggest, because confirm is not a correct word in statistics. We have always suggestion or indication. Right. Here, the probability F value here has to be under 0.05 as well, but don't worry about this one. If the B value here is okay, the probability value will be okay as well. How to take this table out in a publishable format? If I want to take this table out to present it in my research paper or dissertation, the command for that is outreg, outrag2, and then a space using space, you call it anything. For example, you call it Ahmed .doc, and you press enter. One more time, outreg2 using any name file you want, .doc. When I press OK, that will give me a link. If I press on it, I can see the table in a Word file ready for me to have a look on it. Just my computer runs through some securities, but the Word file will open now, and I can see the outcome of the table here. And I'm going to show you how to merge more table, because we don't present in research only one table, right? Here. This is the result, the file called Ahmed, as I name it. This is the return on equity, my dependent variable. This is my gender, independent variable. And this is the result I have here. R square is 0.29%. Number observation is 701. And you have here 3 stars stand for significant at 99%. 2 star mean significant at 95%. 1 star, if there is any, stand for significant at 90%. So as you can see here, stat automatically straight away, but for me, this one is significant at 99%, which confirm what we see there. Can you see 99, 99? So Stata will put asterisks, because the p-value will not exist in this table unless you want. Obviously, you can amend the table, and this is significant at 90%. So 1 star stand for 90%, 2 stars stand for 95%, 3 stars stand for 99%. So I'm going to close this table. If you wish in the Stata to control for the year fixed effect, same model, same everything, but you want to control for the year fixed effect, because different year has different relationship, right? The year before COVID is different the year after COVID. The year before Brexit is different from the year after Brexit. The year when we have recession is different from the year have inflation. So you might argue that the year has a relationship in this model as well. Different year will have a different result. So in order to control for the year effect on your model, you add at the end I small dot, and you write the year. The variable you have in your data set called year, the same as billing, and you press OK. In this case, as you can see, Stata here has controlled for the year. The result even better. R square has went up. The gender diversity significant level has went up. The relationship becomes stronger, and your result is stronger as well. So we control for the year effect, and you can write that in your dissertation or your research paper, that you control for the year fixed effect on the relationship and the result as follow. I will have a look quickly in the chat if someone have question. What if we have 2 dependent variable? We have to run them differently. If you have 2 dependent variable, you have to run them different, like in different time. You can't run 2 dependent variable in the same time. So for example, I run this one, take the data out, run the other one, take the data out. Right? I'm going to show you now. Right? So if I want to take this one again, outreg, to using Ahmed.doc because I need it in command, and I press command, I write replace. Why replace here? Because I don't want the old table. The old table I take away, I already changed something on it. I don't need it anymore. So replace mean I'm telling the Stata to replace the old one with the new one. And I press OK. When I open the table here, I can see only the new table that has done after I add the fixed year effect. So year fixed effect is controlling for the effect of the year on the relationship. As you can see here, and as well you can put in the outreg not to take the year out because there is no point to present this numbers. You can just delete them. There's no point to discuss. You can just write down entire row here and write down one small line, one small row, which is usually used in the literature, and you say here year effect, and in front of it you call yes, I controlled. This is how you write it. You don't have to write all the years because there's no point to discuss the number there. As you can see here, asterisk is 99% again as well, and we have here 99% negative between gearing and the profitability, and we have 99% negativity between current ratio and return on equity. You can also add industry if you think that different industry will have different result. So might wish to add at the end I.industry, right? And when you press I.industry, the database will control for that. If you have the industry, here I have the industry, I group them in 6 groups. So if you have the industry, so the ideal model will be your dependent variable, independent variable, all the controls at the end, I.year and I.industry. Because different industry will have different relationship and different year will have different relationship. So you can quote out, you can minimize the space for the reviewer or the examiner to come back to you by controlling for the year fixed effect and industry fixed effect. As you can see here, R square has improved. Now it's 30%. Adjusted R square is 28. The here as well is improved. Coefficient is better. So this is a better explanatory power for my model. B value is significant in term of gender, is significant in term of current ratio, and is significant in term of gearing. It's not significant for the rest. Border size is significant as well. Right? And you can take this table out, and there is so many ways to do that. You can say, you can replace the title outreg using Ahmed here. And replace mean I don't need the old one. You can replace the title by naming the title fixed effect or OLS, for example, here, OLS. And you can say to Stata add country fixed effect, yes. For example, this is just an amendment to the command to present the table in better format. You can do that manually. Obviously, the number of command that can use in Stata is unlimited, like so many, like enormous command there. You always learn, and I'm just good user here. So myself as well, when I do some command, I found an easier way to run it in the next time. But the main thing that you take out the table outreg use out. You see here, so Stata listened to my command. I said to him outreg using Ahmed.c, replace the title by OLS. So the title is not return on equity anymore. The title is OLS, which is ordinary least square, because I know that my dependent variable is return on equity. I can write it here manually. So I don't want to forget this was OLS regression. And you can see here at the end, he write for me automatically fixed effect, yes, as I asked him to do. I don't need all this year and all this industry. It is enough for me to write industry, yes, year, yes. And enough for me to write industry, yes, and year, yes. Right? So, and obviously there is a command as well. You can tell him, do not take out the industry and year outside. So you tell him, take the table without the industry. But I don't want to overload you with so many commands. Let's keep it simple. So we'll go back to the track again. So I run the command. reg, return on equity, gender, total asset, current ratio, gearing, board size, board independency, audit committee size, and I press OK. And in order to take the out, I checked here the number observation, I check the R square. I only care about the significance. So if your topic of interest, if you are investigating the relationship between gender and return on equity, and here B value is not significant, you might need to find a reason. Some researchers say, no, we have to make it significant when definitely you are missing variables, because that does not go actually with your hypothesis or your search question. If you are claiming in your title, in your literature review, in your introduction, in your discussion, everything barrier the statistical analysis that there is a relationship between gender and return of equity, and suddenly the p-value is insignificant here, like this one, then it's another story in the research method. It's not the best outcome. You might have to find a good justification, or you might need to look in your model what has been missing there, why this result does not come with your previous discussion. So I learn if I want to take this table out, I'll write out reg to using, and I put here Ahmed dot doc comma replace, because I want to delete everything there. That will replace the table. I don't need to open it for you because you already know it's there. What if I want to run a random effect or a fixed effect? Random effects and fixed effect is very easy. At the start of the command, you add xt, and at the end of the command, you write comma and you write fe. This is fixed effect. So at the start of the command, you add xt. So the command will be xtreg, and at the end of the command, you write comma fe, which is mean fixed effect. Here is Tata run a fixed effect, and you can see the p-value has dropped a little bit. It is still significant in term of gender, but I lost the significant in most of my variables, apart from gender and border independency. Fixed effect model, which is xtreg at the end fix, fe, again, we're not explaining research method, but fixed effect model is a strong model. Why? Because one of the main benefits of fixed effect model that is control for the omitted variable bias. So let's say you go to your supervisor, reviewer, examiner, and you have a result, and he will say you have the OLS result, this one, and he will say to you, sorry, you forgot audit fees, because audit fees control the return on equity. Sorry, you forgot the firm age. Sorry, you forgot the firm number of meetings. Sorry, you forgot the firm leverage. So he might come up with many questions to you that you are not able to answer because there is some variable are eventually you cannot put all the variable in the all the variable in the world in your research model. So one of the solution that to cover up the problem of omitted variable bias or non-existence of some important variable is to run the fixed effect model. When you run the fixed effect model, if the result remains significant, as you can see here, that means it's controlled. Any other variable you might add to this research model, statistical model, will not change anything in terms of the significant or the terms of the coefficient of the relationship. The coefficient might go up and down, the p-value might go up and down, but that will remain significant and positive. So the coefficient might change if you add more variable. The p-value might change slightly when you add more variable, but the result will remain significant and will remain positive. So one of the benefits of the fixed effect model is control for the omitted variable bias. It's a strong model to use. So this is one of the important model you run. If the result as you still in your direction, let's say my research question is the relationship between gender and return on equity, it remains significant. That means it doesn't matter how many variable you will add, all the time you will have a significant relationship, positive relationship between gender and equity. So the signal will not change and the significant will not change. If I want to take this table out as well, I'm going to write out reg to using the file I want to say ahmed.doc, comma, and here I don't want to delete the old one. I want to add them together. What I will do, I will write append, append. Append mean do not delete, add. So I will show you now how it looks like. if I press append and I click in the link here, just take some time. Can you see? He doesn't delete. He add another column. So I can call this one in my dissertation OLS, and I call this one to my dissertation fixed effect. I keep them together. And in my discussion, I'm going to say that we run ordinary least square. The result is significant, positive. And after that, we run the fixed effect model. The result remains significant and positive. As you can see here, this is significant at 99%. This is significant at 95%. As you can see, for the obvious reason, here p-value is not under 0.01, it's under 0.05. Right? So the result remains significant in the same direction that confirm my relationship or suggest my model is strong. R square was 29, now is 2% for obvious reason, because fixed effect is much stronger. Some of the variable was significant and now is insignificant. That is normal because fixed effect is more restrict model. But my variable of interest here is gender. So to answer again one more time to the question of your friend Ahmed, Dr. Ahmed Nabawi, I can go and run another command here and replace the return on equity by your another dependent variable, return on asset or audit tenure, for example, another dependent variable, right? So you say, what is the case if I have to dependent variable? You need to run them separately. You run the first model with the first dependent variable and the second model with the second dependent variable, and again outtrig that will be next to each other. Okay, so we learn together now how to do the ordinary least square and how to do the fixed effect model, which is xtreg and at the end fe. The random effect model, instead of fe we write re. Re stand for random effect. Same, xtreg at the end re. Very good. The result, yeah, at 90%. It's in the edge of being significant, but it's still significant. So I can claim, if I take this one outtrig to using Ahmed, the file name I created, .doc, comma, append. Why append? Because I don't want to delete the old one. And I press OK. Make sure you close the file before running append, because if the Word file is open, it will give you an error term if you are repeating with me and you're looking. So the file will open now, the Microsoft Word file will open. And as you can see, the three models are next to each other because I have used append rather than replace. Here, the first model is OLS, and the second model is fixed effect, and the third model is random effect. And you can see that my variable of interest, I don't care about the control much. My variable of interest is the relationship between gender diversity and return on equity. And as you can see, in all the module is positive and significant. So this is a good result for my dissertation if I'm investigating this research question. The relationship between woman in board and return on equity is positive and significant in all the module. Right? There is other tests, but before we go to the other test, I'm going to tell you which one you should choose, random effect or fixed effect, because you have to use one of them only. So when you run the fixed effect here, can you see that? By the way, any command in Stata, if you add in the front of it quietly, the word quietly, that means run this command but do not show me the result. Keep it for you. So quietly mean run this command and store it in the background. Can you see? When I write quietly and I bought the command, he ran already the fixed effect and he bought it in the background. I don't want to see it anymore because I have it here already. Why I'm running it again? Because I want to keep it for another reason. What is the other reason? Now I have to put another command called estimate store FE. And I will bring the last one again, fixed effect, and I brace fixed by random quietly, and I write estimate store random effect. What I did here, one more time. Shall I start from the start? I run fixed effect model. It doesn't matter if you want to quietly or not. Quietly, just I don't want to bother myself by seeing too much table. I want the command to be in front of you so you can see the command. But I'm not bothered to run the command. I run xtreg fixed effect model, and I write estimate store fixed effects or any name you wish. And then I run another time random effect model, xtreg random effect, doesn't matter if it's quietly or not. And I say estimate store random effects. So what happened here? The stata has run the fixed effect and store it, and run the random effect and store it together. All I need to do now is to run Hostman fixed effect random effect. Hostman FERE. This is called Hostman test, and Hostman test to choose which one is good for your data. Shall I go for fixed or shall I go for random? To save the time, because we're going to talk this in detail next week, what you are looking for here, the probability. If the probability is less than 5%, so the stata advising you to take the fixed effect model. In short, obviously, we have to explain a lot of things. So they are running the relationship between the difference between random effect and fixed effect together, but using the Hostman test, and then advising you at the end that the coefficient is not systematic, therefore the probability is under 5%. If you see this last number under 5%, that means you are advised to use the fixed effect. One more time, because if people still in the beginner level, they might be confused now. So quickly, I will wrap up what I did from the start. Quickly, the first thing, I run normal regression model, REG. I check the normal regression model, and I look here in the number observation, R square, the p-value has to be under 5% to be significant. I look in the coefficient and the signal here. So we have a significant positive relationship between gender and return on equity, while we don't have any relationship with asset because the p-value is more than 5%. Current ratio have a significant negative relationship. Every one unit in current ratio reduce the return on equity by -3. We have a negative relationship significant in the gearing. The higher the gearing, the lower the profit. For the obvious reason, gearing is your debt. The more debt you have, the lower profit you will have. Board size is significant at 95% sharp, is in the edge of the significancy. Positive, the bigger the board, the bigger the profit. Then I learn if I want to run fixed effect or random effect, I might choose to run both of them. So I put here XT at the start and at the end FE, which is fixed effect. I might store this result, estimate store fixed effect. I run the command again using random effect RE, and then I store the result as an RE, and I run Hostman FERE. Hostman test is a test to suggest for me which model, random effect or fixed effect, will be more suitable for my data. If the probability of chi square is less than 5%, that means the coefficient is not systematic, therefore advising me to use fixed effect. If this number is 0.9999, for example, or bigger than 5%, that means you have to use random effect. So you don't show the both of them in your result or research paper. You show either the random or either the fixed, and you write in your discussion, based on Hostman test suggestion, we have used fixed effect model. Or based on Hostman test result, we have used random effect model. This table does not have to be reported in your research. It's untabulated table. It's just for you to choose whether you go for fixed effect or random effect. There is another command as well called Tobit regression. We have so many types of regression. The difference between Tobit regression and normal regression, Tobit regression will work if your dependent variable is above 0 all the time. For example, if your dependent variable is gender, so the board of director either have 1 gender, 2 gender, 3 gender, 10 gender, 0 gender. It will never have negative, right? If your dependent variable does not have negative value at all, the best regression model here will be Tobit. So if you are finding the relationship between, for example, gearing and gender diversity, here the OLS is okay, but the most suitable regression model is Tobit regression. And the reason for that, all the gender are falling in the positive area. There is no negative woman percentage, either to be 0% or 100%. Cannot be fall in the negative area. So one of the command is Tobit regression. Take time, Tobit regression take time to run, but this is one of the command you might wish to use if your dependent variable are in the positive section, right? Unfortunately, I have to wait for the Tobit regression result, or I can just force it to stop in order to go to the second step. So let's wait maybe a couple of seconds again. Yeah. So you can hear this is a Tobit regression, does not have any relationship between level of debt and number of 1, obviously, because I just made it up. The p-value is high. So there is no such a relationship between level of debt and the gender in board as a dependent variable. Another one, for example, maybe logit regression and loss regression of if your dependent variable is a dummy variable, 0 and 1. If your dependent variable is dummy variable, it's better to use logit regression, not Tobit or random regression. So logit regression is LOGIT space, you put your dependent and independent. As you can see, based on the logit regression, there is no such a relationship between gearing and the gender. Okay, we'll leave all the additional analysis and robustness analysis for the next class next week, because we have some sampling, subsampling, and etc. Because I want you guys, the best way is to benefit from this workshop is to practice. Otherwise, it will just add up, and you will always forget. So what we said in conclusion, this week we run the OLS regression. We run how to run the OLS with a fixed year effect and fixed industry effect. So you add I.year or I.industry. That will show you the industry and year. And we learn how to take this one out. Let's say now outreg to using any name you wish, as we choose today, Ahmed.doc. And if I put the command replace, that means delete everything and keep only this one. I might decide to run fixed effect xt, add at the end fixed, outreg, and in this case you're gonna put append because I want it together. You might choose random effect RE, and you put again outreg append to add a column on it. You might get the reg as well itself and add at the end robust, which is robust OLS regression, and again outreg using Ahmed.uc append. If I open this file, I should see all the 4 models I have used to test the relationship between gender and return on equity, which is give me confidence to write in my discussion area. This is my main analysis or my main table. The first table in my regression analysis, I have to explain in detail that what I see there, whether it goes with my expectation, theoretical framework, hypothesis development, or I go against my expectation. Here you can see all the 4 commands. The first one was OLS. You can name it by the way using stata. The second one was fixed effect. Third one is random effect. And fourth one was robust, if I remember correct. All of them, in terms of my variable of interest, if I change the layout to be oriented landscape, all of them in terms of my variable of interest is significant and positive relationship. As you can see from here, we look in the p-value all the time. We look in the p-value all the time. P-value is under 0.05, that means it's significant. So we look in the coefficient level. If it's positive, that means I have a direct positive relationship between gender and return on equity. If it's negative, that means we have a negative relationship. right? Maybe, so this is will cover the regression model and robustness check using fixed effect and random effect. Next week, we might go through the additional analysis, subsampling, GMA model, 2SLS model, and after that, the following week, we might discuss the indigeneity and the other problem in our regression result. But my best advice to you, this is the most important class today, because this is the main empirical result of you. So if you are a new user to Stata like myself, just go and try to practice today before you forgot, especially the command. And you can always, as we learned before, store your command, Control A, copy all the command, Windows, do file, and store all your command in a do file. So you can go back to it and check if you want to add variable, you can add it there and run all the files straight away from here. You can execute all the file in one go. For example, after 1 week, my supervisor said, remove the current ratio from the model. I will remove the current ratio from my do file, right? And I will press execute the do file. Do file will straight away execute all the table together from the stata command. Let's see the Q&A. What if I have two dependent variable? I said that, okay, that the recording is there. Will be the dynamic will be discussed in further rehearsal. Yes, but might be after week number 5, because we are focusing in the banal data regression now. But yes, we might go and check the dynamic models later on. The difference between logistic regression and probit regression. Again, I'm a good user of Stata. I'm not expert in everything. Probit regression, if your independent variable is dummy, logit regression if your dependent variable is dummy. But to answer your question, Saleh Ali, the probit regression can be run by, you put at the first, instead of reg, you write probit. Right? So here, probit, and you can just need to remove the word result. Or you can go here and write mixed regression as well. Or GLS regression. You see many type of regression there. But which one to choose, it depends on your type of variable. We are not discussing research method because I'm not expert enough to answer your research method questions, or I'm not prepared enough immediately now, because question is endless. You can ask in everything. I'm not a statistician. I'm using it in my research, so I might able to answer some of your question. So, for example, if you look in the mixed regression, is between variable fixed and random, and result is still significant. GLS regression is different. So we have different type of regression and different type of result that can execute there. Again, it's how to use Stata is not about research method. Right, I will share the do file with you later on after the class if you wish. But I finished the OLS and the fixed effect and random effect. I'm happy to answer any question if you have. I'll stop sharing my screen. I'll look in the Q&A. I think we answered to the latest one. What is a robustness test? Robustness test reduce the error term. Amal Hassan, Dr. Amal, robustness test is to reduce the error term. So reduce the error estimate in my module. So the improving the error term. How to use the fixed effect as a robustness test? This is what we did during the class. You run the OLS and run the fixed effect after that. So here, if I share my screen one more time, in the Word file, here I use the fixed effect as a robustness test. That's it. You might make it in a different table under title core robustness check, or you might keep it here. And when you are writing, we robust our result. Robustness means you are checking a result. Okay, we robust our result by checking the fixed effect model, and we'll find the result remains significant. This is how to use the fixed effect as a robustness test, and this is how to use the random effect as a robustness test. So for answering for Amal, here this usually the robust will give you the same result like the main OLS, but the error term will be changed because it will reduce the impact of the error term. Again, it is a semester question, and to answer that in detail, other people might lose the focus of the class. Last question was Amal. If I want to check the identity effect, how can we interpret the Stata outcome? Identity effect. So again, this is anything. You can check anything effect if you put here I dot at the end. So if I run reg and at the end here, I put, for example, I dot Eisen. This will control for the Eisen identifier of the firm. That means will control for every single firm. The table will be very lengthy. See, because the Eisen is a string variable. We forgot that we replaced it by group ID last time, if you remember. The control for the group ID, look, it's control for the each single variable in the stata, each single variable in the data set. The result here is much more stronger, by the way, because what you can claim to your supervisor or to your reviewer or your examiner now, we have controlled for different firm effect on the relationship. One more time. The last command here, I can add to it I dot year to control for the impact of the year on this relationship, I dot industry to control for the industry effect on the relationship, I dot group ID to control for the each firm relationship. Because McDonald's as a firm will be different from Microsoft. Microsoft is different from Burger King. Burger King is different from British Gas or Tesco or supermarket. So each firm will have different characteristics. So you can control for the identity, just adding I dot the identity number at the end. And when you take this file out, you don't have to present everything from that. You just write year, yes, industry, yes, firm ID, yes.
We have a question after you answering, Doctor, with the RDM threat.
Okay. Do I need to add the control variable with dependent variable and independent variable always while doing the reg? Yes. Sayyida, yes. You have to run the regression in full. You have to make sure you have controlled for all the common variable have you been used in the literature. Okay.
You answered my question. Thank you. I asked about the dynamic analysis, but you said it will be further discussed in the coming lectures.
Yes.
So thanks.
Thank you very much.
For
our main focus for this week and the coming week as well will be for panel data. And after that, we might look for the dynamic model later on. Saleh, Ali? Thank you very much. Saleh, you can unmute yourself and ask the question.
Saleh, please unmute your mic so we can hear you, please. Okay, Doctor, you can continue in the Q&A.
Okay. So yes, so I'm looking at the Q&A now. The last question was from Sayyida. We have answered that. We have question from Farah. If we want to check the identity effect, yeah, we answered that already. So in the stata outcome, you just need to write firm, fixed effect, yes. You don't have to present the number there. Ahmed al-Nabawi, we already answered that. Two dependent variable. I couldn't see any other question, guys. If your question has not been answered, please type it again. I think I have addressed all the 8 questions I can see in the Q&A.
في question بالchat, Doctor, from Reem. Should we report the result with and without the controls?
No. Okay. So this is very interesting question. Dr. Reem is saying that how to report this table at the end. Most of the papers in 4-star or 3-star journal, it depends where are you in academia now. So if you are still a PhD student or master student, we expect you to present everything to make sure they have you included the correct control variable. So if this is customer as a master thesis, came as a master thesis or PhD thesis, I assume that you have control, both all the control variable, and sometime we require the student to discuss some of them as well. So yes, the main control here, the main variable of interest is gearing, but the student has to provide some discussion why the border size is positive significant, which is agree with the literature, why the independency is negative, which is disagree with the literature, why the gearing is negative significant here. So the student will require some further discussion around their control. In the PhD level, again, the student has to discuss all the variables because the thesis is so big. When it comes to publication, if you're in that stage, so there is two ways. The first way is to present all the table and discuss only the variable of interest, right? Because we're not examining your capability of writing or academic of interpreting the result. This is not a question now. You are on a higher level than that. So therefore, if you have your variable of interest only gender, assets, and current ratio, you only discuss these three, ignoring everything else, just presented in the table. And another way, I just said in the chat, some of the author ignore reporting all the control. So what they will do, they will delete all of that here like that. And they will put only one line, and they call it controls. You can write here controls. And in front of it, you're going to write yes, 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 yes. That means we have control for the important variable required. I don't want you to bother you as a reader by having a lot of number. I want you to just focus on my variable of interest. So there's two ways in publishing a paper. The first way, we include all the control, so the reviewer know, and he might come back to us and catch us to increase the number of variable or delete variable, adding variable. Or another way, we don't want to report the controls. We only report our variable of interest. But this is for the publication. If you are a master student or a PhD student, you should present all the controls, discuss them in detail, because this is one of your examination point of view, how you interpret number and how you write a good comprehensive critical discussion. I hope this answers your question. Reem, yeah, you're welcome, Dr. Reem. Any other questions, guys?
I think that's it, Dr. Mahmoud. Thank you so much for your time and for your effort. Looking forward to our next lecture, inshallah, next week at the same time, same day. And I will post the registration, inshallah, soon, tomorrow or the day after tomorrow, inshallah, for anyone who want to register. Regarding the first lecture and today lecture, it's already recorded. It's already recorded, and you can see it in the YouTube. I will share the link in the chat. Give me a second, because I received many emails regarding the
recording. Yes,
the recording, and I keep sending it by emails, but let me share it in the chat so everyone have it. This is for today one. Okay, this is for today, and you can see also the first lecture as well. Thank you so much, Dr. Mahmoud, and looking forward to see you, inshallah, next week. Thank you so much, and have a good night.
You're welcome. Thank you very much. Thank you.